Imagine this, we've got a press tool with a strip of material coming out. There's got a little bit of bounce to it as this machine moves, there's a lot of vibration going on and this material is bouncing up and down. You can imagine that when we're looking at that through a camera, it's getting bigger and smaller, bigger and smaller. Why does that happen? Well, because a standard lens looks out in a cone shape. That means that things that are closer to us occupy more of the field of view, so they appear bigger than things that are further away. But if our job is to measure that strip of material coming out, then that's going to cause us a real big problem. That's when we turn to a telecentric lens. Unlike a normal lens, which is looking out at an angle, a telecentric lens has got a sequence of lenses in there that allow it to correct for that, and it looks out in a straight column, which means things that are closer to us don't appear bigger than things that are further away. They appear the same. They'll go in and out of focus as we move it to and from the camera, but never bigger or smaller. That means that we can measure that strip of material without any loss of accuracy. You typically use telecentric lenses when you want a high precision measurement. It also gets rid of that optical distortion. Imagine you've got a 10mm aluminium plate with lots and lots of holes in it. If we wanted to accurately measure those holes, the only one that we can see through perfectly is the one directly in the middle of our field of view. The ones at the edges, suddenly as we're looking out, we're not looking through the hole, we're looking at the sidewall of the hole, and that's no good. With a telecentric lens, we're looking straight down and we can perfectly see through all of those holes, regardless of how they move in our field of view. It gets rid of that lens distortion that we're all used to seeing. We've recently solved an application for a customer where they've got a round part with a square section that comes out of it. They wanted to check to see if it was bent by comparing the centre of the square to the centre of the circle. Well, the problem is with a standard lens, as that started to move off centre in our field of view, we're no longer looking down on it, we're looking side onto it, and that's no good. So we gave them a telecentric lens with a big depth of field so that the square and the circle were in focus and we could accurately compare those regardless of where it moved around our field of view. Now, pericentric lenses. No, don't worry. There'll be another video on that.